All right, our second video today, again, trig review, getting ready for calculus. Not teaching, just reviewing. These are things you should know, and maybe you've forgotten, just need a quick review. We got to talk about reciprocal identities, cosecant, secant, and cotangent. Remember, when I write sine -1 of A over B, I am calling out an angle here. I'm not saying 1 over sine. All right, this is an angle. If I draw this triangle, let's see, A over B, and I'll have to put the angle A here. This would be A equals, right? This is what we have when you see this. So if I want to divide by sine, we needed a new system. So we needed some other identities, and that's what they developed here. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. And if you want, remember, sine is 1 is the opposite over the hypotenuse. So I can skip this, and we're used to this from our work of algebra 2. This is the hypotenuse over the opposite. This is the hypotenuse over the adjacent. This is the adjacent over the opposite. All right? And again, just another way for us to do this, so we have methods. We'll do some actual trig identities using these in the next video, or the video after that as I set these up. But again, for now, we're just making sure we understand we have these three. Again, these have to be memorized along with the things in the first video, SOHCAHTOA, law of sines, law of cosines. To talk very quickly, we should be familiar with this, but any point can be represented not only by an xy coordinate shown here, but can be represented by some distance, which most textbooks call r, and an angle theta, and be equivalent to each other. And when we make this point, we should see that we have a triangle where the x and y distance are here. In this case, x is -½ y is square root of 3 over 2. You should see Pythagorean theorem. And again, we can solve for these things, and that allows us then, for this angle of theta, all right, we can do this work, and we can come up and write these identities off of this. We can say sine of theta in this case would be y over r. Cosine of theta in this case would be x over r. Tangent of theta would be y over x. We should be able to see all this in our triangle right here because it's a right triangle. And if I want to do the reciprocal functions, I can, just so we make sure we see them. Cosine theta would be r over y. Secant theta would be r over x. And cotangent theta would be x over y. And again, x and y can't be 0. That's a unit circle problem when those are 0. We'll get to that in another video. But again, we have to understand this because this leads us to what I call in my classroom the bow tie. We can locate a triangle in any quadrant. And we should quickly see here that in quadrant 2, cosine is going to be negative, and sine is going to be positive. And I talk about all the time when we set this up. X is cosine, y is sine when the radius is 1. All right? And it's a big deal for our unit circle. But anytime I have this, I can draw 4 triangles. And the reference angle of all 4 would be the same. I called it theta and I marked it in blue. And in the quadrants. And we should see that in quadrant 1, sine and cosine are both positive. Because the distance out is always positive from the origin. All right? I always joke about marching somewhere and your origin is the home in the middle. All right? We have to have a couple other identities to make things go quickly. I don't memorize them. I draw the figure there and I visually make sure I understand them. Recall that the cosine, if I look in quadrant 1, the cosine of this triangle is obviously positive. And if you look at the cosine of this triangle, it is also positive. Now the sine is negative in quadrant 4, but the cosine is positive. So the first line is that, hey, cosine in quadrant 1 and 4 are the same. Likewise, the only difference between the sines in quadrant 1 and 4 is the sine. Okay, and again, this should make sense to you. If you need more review on this, you can type it into the internet. Again, this is a review video to be ready for a placement test. We also should know that pi radians equals 180 degrees, and that we can talk about these this way. There is pi, and there is 180 degrees. But this allows us to solve multiple triangles. And often they bound it, right? They say 0 to 2 pi or 0 to 360 degrees. All right? So that there are not multiple answers. But if I say, again, my favorite one is, say, cosine of x equals, we'll do it in degrees first, is 1/2. I always talk about, can you draw the triangles? Do you know what quadrants you're going to be in? In the triangles this time, obviously, cosine is positive here because the x is positive, and it's positive there. And again, adjacent is 1, the hypotenuse is 2. Adjacent is 1, the hypotenuse is 2. We should be very familiar, and I haven't talked about some videos, but at this point, good chance for us to talk that we have memorized and are very comfortable with our 45, 45, 90, and our 30, 60, 90. If you do not have these completely memorized correctly, it's an absolute necessity you know these. So you look at this and you should automatically see, right, that the 1 and 2 is based off of 60 degrees. So the reference angle on this one is 60 degrees of both these triangles, the black right here and right here. So my answers from 0 to 360 are 60 degrees, boom, and 360 minus 60, how about 300 degrees? And again, I'm not teaching here. We're reviewing it. This does not make sense. You need to get back into it or you're in the wrong video. I have a couple more examples just to make sure we're clear. And it does not have to be easy. And when they do this, you know the bound is in radians and want the answer in radians. All right, so 0 to pi, that's 0 to 180. So it can only be in quadrant 1 and 2. So I want to draw this. Tangent is sine over cosine. All right. When I think of positive sine and positive cosine in quadrant 1, that doesn't get me negative. When I think of quadrant 2, negative cosine, positive sine, that does make a negative tangent. And if I draw the triangle, it should come right out. And I'll call that reference angle A. Opposite, which is positive 3, and then it's obviously negative 7 you get here. If they want you to find theta, there's a couple ways to do it. I would probably ask them this question, what the angle is, so you can type in your calculator, just type in A is going to be the inverse of 3/7 in my calculator. 3 divided by 7, about 23.2 degrees. That is the reference angle. Now, again, a calculator often, if you do it with the sign, will pump out the answer you want. But in this case, if you do it in your calculator, and you type in negative 3/7, it gives you negative 23 degrees. All right? It doesn't put you in the correct quadrant. So that's why we don't do sine. But I don't want that angle. I want this angle. Well, you should see that theta and A are going to be supplementary. They sum to 180, so 180 minus 23.2. Well, 156.8 is the answer. Degrees. Okay, but I want radians. So let's do our quick conversion. Pi rads are equivalent to 180 degrees. And maybe your calculator has a button. If you do, go ahead and use it. I mean, especially on a placement test, there is no reward for not using your resources. But again, this allows us to quickly do these problems, and we should be able to work back and forth between them. The next step in the next video will be moving to the unit circle. But we should be able to handle simple trig identities like this. And if I put these on the board, we should be able to handle sine of theta equals negative square root of 3 over 6. And maybe I would say between 0 and 360, and you should be able to do this with your calculator. And again, this is not one of the standards. This is not a 30, 60, 90. Again, those are typically easier, all right? But you should be able to say, yeah, I know sine is negative in quadrant 3, in quadrant 4. I know those angles here will be the same. I'll call it A again for a reference angle. Square root of 3, there's your negative. 6, square root of 3, there's your negative. It's down below the axis. 6 is positive, but it gives you a negative sign. Your calculator is an amazing tool. 3 square roots divided by 6, take the inverse sign. And again, I'm taking sine negative 1, or square root of 3 over 6. When I get that, I get 16.7, A is 16.8 degrees. And again, if you take the sine negative 1 of the negative square root of 3 over 6, your calculator is just going to give you one answer. It's going to give you the arc one of negative 16.8 degrees, which is just that triangle. All right. Remember that if I want that, I can say, hey, arc sine theta equals negative square root of 3 over 6. Go ahead and use your calculator then, because it's going to pump out the answer in quadrant 4, but that's not what this problem was. So the answer here, and again, both of them, you should see that quadrant 3 is 180 plus 16.8. So how about 196.8 is one answer, and 360 minus is 343.2 degrees, because our domain at the top said from. Again, keep studying. This should all be pretty straightforward. And again, practice makes perfect.